Hello everyone, this is Meenakshi Dilip Birari, working as assistant professor in chemistry at Maratha Vidya Prasarak Samaj, Nasik. In previous lectures, we have studied the chemical kinetics. Now, we are going to start the second chapter of physical chemistry, that is surface chemistry. In today's lecture, we will study the mechanism of adsorption, types, characteristics of adsorption, and also factors affecting adsorption. In this unit, we have to study Introduction to Surface Chemistry and also some basic terms related to surface chemistry, factors affecting adsorption, characteristics of adsorption, types of adsorption, classification of adsorption isotherms, Langmuir adsorption isotherm, Freundlich adsorption isotherm, bed theory, and applications of adsorption, and also numericals related to surface chemistry. So all these topics we have to study in detail one by one. First of all, in today's lecture we will study the mechanism of adsorption, factors affecting adsorption, types and characteristics of adsorption. So let's move towards today's lecture. First of all, what is surface chemistry? Surface chemistry deals with the study of physical and chemical phenomena that occur at the surface or interface at two phases, including solid-liquid interfaces, solid-gas interfaces, solid vacuum interfaces, and liquid-gas interfaces. The interface or surface is represented by separating the bulk phases by a hyphen or a slash. For example, the interface between a solid and a gas may be represented by solid gas, that is solid hyphen gas, or solid slash gas. Due to complete miscibility, there is no interface between the gases. So we should remember there is no interface between the gases due to complete miscibility. So we know that surface chemistry, it deals with the phenomena that occur at the surface or at the interfaces. That surfaces that may be solid liquid interfaces, solid gas interfaces, or solid vacuum interfaces. But due to complete miscibility, there is no interface between the gases. The bulk phases that may be pure compounds or solutions, the interface is normally a few molecules thick, but its area depends on the size of the particles of bulk phases. The interface is normally a few molecules thick. Many important phenomena that occur at interfaces are adsorption, corrosion, electrode processes, heterogeneous catalysis, dissolution, and crystallization. The subject of surface chemistry finds many applications in industry, analytical work, and also in daily life situations. To accomplish surface studies properly, it is important to have a really clean surface. Solid materials with such clean surfaces need to be stored in vacuum, otherwise these will be covered by molecules, namely oxygen and nitrogen gases. So under very high vacuum of the order of 10 raised to minus 8 to 10 raised to minus 9 Pascal, it is now possible to obtain ultra clean surfaces of the metals. So to accomplish surface studies extremely careful and precise, it becomes important to have a really clean surface. So this chapter deals with some important features of surface chemistry such as adsorption, catalysis, and colloids, including sols, emulsions, and gels. So let's see in detail about the adsorption, the mechanism of adsorption, and also the examples of adsorption. There are two types of molecules, bulk molecule and surface molecule. Surface molecules have different environment than bulk molecules. Therefore, surface molecules behave in different manner than the bulk molecule. Bulk molecules in liquids surrounded by many other molecules therefore experience the balanced symmetrical force of attraction from all directions. So here this bulk molecule experiences the balanced symmetrical force of attraction from all directions, whereas these surface molecules in liquid are not surrounded by all sides. Therefore, it experiences unbalanced symmetrical force of attraction. So here the molecules on the surface of a liquid behave in a different manner than the molecules in the bulk. The reason behind this is that the molecules on the surface are subjected to an unbalanced attraction from the liquid side, which tend to drag the molecules inside the liquid. So these molecules are unbalanced attraction from the liquid side, which tends to drag the molecules inside the liquid. The surface layer has therefore free energy or surface tension different from the rest of layers in the bulk of the liquid. Similarly, the attractive forces of the atoms or the molecules at the surface layer of a solid are not fully satisfied as in the interior of the solid. In short, we can say that the surface of a liquid is in a state of strain or unsaturation, and that of a solid has similarly a residual or unbalanced field of force. So it can be explained by using this image. Here the bulk molecules in liquids are surrounded by many other molecules and it experiences the balanced symmetrical force of attraction from all directions, whereas the surface molecules in liquid are not surrounded by all sides, therefore experience unbalanced symmetrical force of attraction. It is known that there is a tendency for the free energy to decrease. Any surface possesses the free energy or surface tension and thus ultimately responsible for the phenomena of adsorption. So we can summarize that the molecules are of two types, surface molecules and bulk molecules. Surface molecules are unbalanced, unstable and having higher energy, whereas bulk molecules are balanced, stable and having low energy. So it is known that there is a tendency for the free energy to decrease. Any surface possesses the free energy or surface tension and thus ultimately responsible for the phenomena of adsorption. So what is adsorption and what are the examples related to adsorption? How we can define adsorption? Let's see in detail. Adsorption, it is a surface phenomenon. So what is the definition of adsorption? How we can define adsorption? The phenomenon of concentration or assimilation of a gas or a liquid at the surface of a solid or liquid with which it is in close proximity or contact is called adsorption. Simply, the collection of a substance on the surface of another substance is known as adsorption. The collection of a substance on the surface of another substance is known as adsorption. It is a surface phenomenon. Alternately, adsorption can be defined as the change in concentration at the interfacial layer between two phases of a system. The material providing the surface upon which adsorption occurs is known as adsorbent, and the substance adsorbed or attached is called adsorbate. So we should remember what is adsorbent and what is adsorbate. The material providing the surface upon which adsorption occurs is known as the adsorbent, and the substance adsorbed on or attached is called adsorbate. So what are the examples of adsorption? Adsorption is expected when two heterogeneous phases are brought in contact with each other. Hence, there are three cases of adsorption, that may be gas solid, liquid solid or gas liquid. For example, adsorption of a gas by charcoal, adsorption of a dye by charcoal, purification of raw sugar and removal of moisture from air. Also, adsorption of acetic acid in charcoal system, where charcoal is the adsorbent and acetic acid is the adsorbate. So what is adsorbent? The material providing the surface upon which adsorption occurs. It is known as the adsorbent. So in the acetic acid charcoal system, charcoal is the adsorbent and acetic acid is the adsorbate. Now there is difference in between absorption and adsorption. These are two like terms, but we should remember it is absorption and it is adsorption. So what is this concepts? First of all, what is meant by absorption? In absorption, the substance is uniformly distributed throughout the bulk of the solid. In the absorption process, a substance is not only remained at the surface, but it is distributed throughout the body of a solid or liquid. Thus, when a sponge is left in contact with water or chalk in contact with ink, the liquid in each case is absorbed and penetrates into the adsorbent. Now the second thing, that is adsorption. How we can define adsorption? In adsorption, the substance is concentrated only at the surface and does not penetrate through the body of the solid. For example, stored in water. So, absorption, the substance is uniformly distributed throughout the bulk of the solid, whereas in adsorption, the substance is concentrated only at the surface and does not penetrate through the body of the solid. So we can consider few examples. By using that, we can distinguish these two terms. One is absorption and second one is adsorption. So first example, here we can see that when a sponge is left in contact with water, there is all the water molecules are uniformly distributed throughout the bulk of the solid. That is, throughout the bulk of the sponge, all the water molecules are uniformly distributed. Second example, that is gulab jamun. So here sugar syrup, in that sugar syrup the gulab jamuns are dipped so that the sugar syrup is uniformly distributed through the bulk of the solid. Then the another one, chalk in water or chalk in contact with ink, the liquid in each case is absorbed and penetrates into the absorbent. Again, tea biscuits, in this also the liquid is absorbed and penetrates into the absorbent. So these are few examples. By using, we can guess that what is absorption. In each case, the liquid is absorbed and penetrates into the absorbent. So absorption, the substance is uniformly distributed throughout the bulk of the solid. Another one, adsorption. So what are the examples of adsorption? So it is the example of silica gel. So water vapors adsorbed by silica gel. And the another example, that is activated charcoal. So here also the substance is concentrated only at the surface and does not penetrate through the body of the solid. So from these examples we get that what is absorption and what is adsorption. So in adsorption, the substance is concentrated only at the surface and does not penetrate through the body of the solid. Whereas in absorption, the substance is uniformly distributed throughout the bulk of the solid. So we should remember this one is for adsorption and it is for absorption. Again, this example, it is related to adsorption where the water droplets are adsorbed on the leaves. Now, some basic terms which are related to surface chemistry. First of all, adsorption, the accumulation of molecular species at the surface rather than in the bulk of a solid or liquid is termed as adsorption. We have studied adsorbate. What is adsorbate? The substance which is being adsorbed on the surface of another substance is called adsorbate. Then adsorbent, the substance present in bulk on the surface of which adsorption is taking place is called adsorbent. That means the substance which adsorbs the another substance is called as adsorbent. Another term, desorption, the process of removing an adsorbed substance from a surface on which it is adsorbed is called desorption. So it is the reverse to the adsorption, that is the process of removing an adsorbed substance from a surface on which it is adsorbed is called as desorption. Then absorption, it is the phenomena in which a substance is uniformly distributed all over the surface. Already I have explained what is the difference between adsorption and absorption. The another term, sorption, when adsorption and absorption take place simultaneously, it is called as sorption. So we should remember these basic terms related to surface chemistry: adsorption, adsorbate, adsorbent, desorption, absorption and also sorption. So we can distinguish these two terms. One is adsorption with absorption. What is adsorption? The molecules adhere to a surface of the material. And here, what is absorption? Molecules are drawn into the material. So there is difference between adsorption and absorption. In absorption process, a substance is not only remained at the surface but it is distributed throughout the body of a solid or liquid. Whereas in adsorption, molecules adhere to a surface of the material only. What is adsorbate, adsorbent? We have studied now. The substance which adsorbs another substance is called adsorbent, and the substance which is being adsorbed is called adsorbate. Solids, mainly in finely divided state, acts as a good adsorbents. For example, silica gel, charcoal, surfactants and colloids that may be used as a adsorbents. So materials having high specific surface area, porosity and capacity or tendency to adsorb another substance are known as adsorption materials, which are also called as adsorbents. So different examples we can take: activated charcoal, silica gel, surfactants, colloids, synthetic zeolites, natural zeolites, ion exchange resins, sodium bicarbonates, potassium permanganate, etc. Now let's see the distinguishing points related to adsorption and absorption. We have studied adsorption and absorption. So what is adsorption? It is surface phenomenon. Absorption, it is bulk or body phenomenon. In adsorption, there is accumulation of molecules with high concentration Whereas in absorption, distribution of molecules throughout the body. Adsorption depends on temperature and pressure. Absorption is independent of temperature and pressure. Adsorption is proportional to surface area of adsorbent, whereas absorption is independent to surface area. Adsorption, this process is a fast process, whereas absorption, it is a slow process. In adsorption, equilibrium is attained quickly, whereas in absorption, the equilibrium is attained very slowly. Adsorption, it is a reversible process, and absorption, it is a irreversible process. So we should remember there is a difference between adsorption and absorption. So adsorption, it is a surface phenomenon, whereas absorption, it is a bulk or body phenomenon. It is a reversible process. Absorption, it is a irreversible process. So these are few examples of adsorbent: cotton, granular industrial absorbent, absorbent pulp or absorbent polymer. These are the few examples of adsorbent: alumina cream, fuller's earth, activated charcoal, zeolites, like that. Now the another concept, that is what is sorption. When adsorption and absorption take place simultaneously, it is called as sorption. So when doubt exists as to whether a process is a true adsorption or absorption, McBain proposed the term sorption for the combined effect of the processes. So what is sorption? It is a combined effect of the processes of adsorption and absorption. When adsorption and absorption take place simultaneously, it is called sorption. So already we have studied what is adsorption and absorption. In absorption process, substance is not only remain at the surface, but it is distributed throughout the body. In adsorption, the substance is remained only at the surface, and whenever there is a doubt whether a process is a true adsorption or absorption, McBain proposed the term sorption for the combined effect of the processes, that is when adsorption and absorption take place simultaneously, it is called as sorption. So it is the example related to sorption. So in this you can observe both adsorption and absorption take place simultaneously. So it is called sorption. Now let's see the types of adsorption. There are two main types of adsorption: physical adsorption and chemical adsorption. Depending upon nature of force between adsorbate and adsorbent, there are two types of adsorption process. One is physical adsorption or van der Waals adsorption, and chemical adsorption or activated adsorption or chemisorption. So first of all, what is physical adsorption, physisorption, van der Waals adsorption? The difference between these two types arises due to the nature of the forces which are responsible for adsorption. So we shall discuss now each of these two types together with their characteristics. First of all, physical adsorption. When a gas is adsorbed on the surface of a solid by the weak intermolecular forces of attraction or van der Waals forces without the formation of any chemical bond between the adsorbate and the adsorbent, is called physical adsorption. So whenever a gas is adsorbed on the surface of a solid by weak intermolecular forces of attraction without the formation of any chemical bond between the adsorbate and adsorbent, is called physical adsorption. The second one, chemical adsorption, when the forces of attraction existing between adsorbate and adsorbent are chemical forces of attraction or chemical bond. This process is called chemical adsorption. So depending upon nature of force between adsorbate and adsorbent, there are two types of adsorption processes. So here intermolecular force of attractions, weak intermolecular force of attractions or van der Waals forces are present, and here the force of attraction existing between adsorbate and adsorbent are chemical forces or chemical bond. These physical adsorption and chemical adsorption, when we explain, in this type of adsorption, the gas molecules are held on the surface of the adsorbent by van der Waals forces, and in chemical adsorption, the force of attraction, that is by chemical bond between the adsorbent and adsorbate. Physical adsorption is characterized by low heats of adsorption, and chemical adsorption, it is characterized by high heat of adsorption. Physical adsorption may be found in all instances, for example gases like H2, N2, CO, CH4, NH3, Cl2, SO2, etc. The chemical adsorption is found only when there is a tendency towards compound formation between a gas and adsorbent. So let's see the distinguishing points related to physiosorption and chemisorption, that is physical adsorption and chemical adsorption. Physical adsorption or van der Waals adsorption. The forces of attraction are van der Waals forces. In chemisorption, the forces of attraction are chemical bond forces. Physical adsorption is characterized by low heat of adsorption, low enthalpy of adsorption, that is in between 20 to 40 kilojoule per mole, whereas chemisorption, it is characterized by high enthalpy of adsorption, about 200 to 400 kilojoule per mole. Physical adsorption, this process is observed under conditions of low temperature, whereas the chemical or activated adsorption, this process takes place at high temperatures. Physisorption, it is not specific. Chemisorption, it is highly specific. Physical adsorption, in that multimolecular layers may be formed, whereas in chemical adsorption generally monomolecular layer is formed. Physical adsorption is reversible process, whereas chemical adsorption is irreversible process. Physical adsorption is reversible and equilibrium is established rapidly. The process is easily reversed either by raising the temperature or either by lowering the pressure. Whereas chemical adsorption is rarely reversible, that is desorption is difficult. To remove the adsorbed gas, the solid must be heated to a higher temperature and pumped at a high vacuum. So this process is irreversible, whereas physical adsorption is reversible process. Normally the physical adsorption does not involve any energy of activation, and chemical adsorption, it requires the activation energy. So all these are the distinguishing points between physical adsorption and chemical adsorption. Now we have to study the factors affecting adsorption. So what are the factors which are related to the adsorption? These are nature and surface area of adsorbent, nature of gas, temperature, pressure, reversible nature exothermic nature and specific nature. So we have to study in detail factors affecting adsorption one by one. First of all, nature and surface area of adsorbent. As adsorption takes place on surface of substance, hence extent of adsorption is directly proportional to surface area of adsorbent for given mass. The extent of adsorption can be increased by activating adsorbent and can be achieved by making their surface rough by mechanical rubbing, chemical action and removing volatile impurity or other process. For example, wood charcoal is activated by heating between 350 degrees Celsius to 1000 degrees Celsius. Hence, free surface are made available for adsorption. So, as the adsorption takes place on the surface of the substance, hence the extent of adsorption is directly proportional to surface area of adsorbent. Another factor, nature of gas. The gases which are easily liquefied, which are having higher critical temperature and highly soluble in water, are adsorbed to greater extent. So, the gases which are easily liquefied and which are highly soluble in water are adsorbed to a greater extent. The another factor, temperature. Extent of adsorption varies inversely with temperature. Lower the temperature, higher is the adsorption, or higher the temperature, lower is the adsorption. So it is inversely proportional with temperature. Extent of adsorption is inversely proportional to temperature. Temperature increases, the extent of adsorption decreases. Another factor, pressure. If adsorbate is gas, then adsorption increases with pressure of gas. However, once the active site are occupied by gas, the further increase in pressure has little or no effect on amount of gas adsorbed. Reversible nature. It is also one of the important factors related to adsorption. The equilibrium of adsorption is strongly affected by temperature. The adsorbed gas can be recovered by increase in temperature and decrease in pressure. This removal of adsorbate from surface of adsorbent is called desorption. Exothermic nature. Adsorption undergoes exothermic process and the heat evolved in adsorption is called heat of adsorption. Then specific nature. Adsorption of gases by solids be selective. For example, from mixture of ethylene and coal gas, charcoal adsorbs ethylene only. So that adsorption of gases by solids may be selective. So these are the various factors affecting adsorption. We have studied nature of gas, temperature, pressure, reversible nature, exothermic nature and also specific nature. So in today's lecture we have studied the mechanism of adsorption, factors affecting adsorption, types and characteristics of adsorption and also the distinguishing points with adsorption and absorption. Thank you.